is. So I first want to quickly go over general information characteristics. Some of this you should know, and some of it will be newer. So acids. One of the ways that we are going to recognize a chemical formula of a solute that functions as an acid, the way that we are going to see it written is the chemical formula will start off with an H, and it will be followed by some sort of nonmetal. That could be an individual nonmetal or a polyatomic. So we could see something like HCl versus H2SO4. But because both of these chemical formulas start off with hydrogen followed by nonmetals, we're going to recognize that these can function as acids. The acids that you need to be most familiar with, common acids, they are listed on our reference table K, where you will find chemical formulas and their names. So here is the key with acids. These are molecules that produce a H plus hydrogen ion in water, in solution. And so the H plus ion, this is our key factor of why a solute functions actually as an acid, because it produces that H plus ion. Now, there are variations in which we're going to see it represented. So simply, we will see it represented as H plus. So that would be referred to as a hydrogen cation. Another way that we will have to get used to see this idea represented will look as H3O plus, and this is a polyatomic that we know as the hydronium ion. Okay, and a lesser known way, but I'm going to throw it out there, is the H plus can also be referred to as a proton, because the only thing that is left in the structure of this is the proton in the nucleus. The only electron has been stripped away. This is less common for us. Okay, so now pH. The pH scale would be something that you have heard of and maybe worked with a little bit. Okay, but an acid, it has a pH value that is less than 7.0. So if the pH value is less than 7.0, okay, then we realize it's an acid. And the reason that this value is less than 7 is due to a higher concentration of the H plus ions in solution. So the higher the H plus ion concentration, the lower the P number. Now acids, you have probably tasted acids in food because there's lots of foods that are acidic by nature, but they tend to taste sour. And if you have a really strong acid and it gets on your skin, it will actually burn the skin. Acids function as electrolytes. They conduct electricity. Now, a couple of reactions that acids participate in that we have already talked about is that an acid will participate in a neutralization reaction when it reacts with a base. And acids will also react with metals to produce H2 gas. And that's simply a table J type of question. Bases. For us, we only really take a look at one type of base, so the way we're going to recognize it is a metal that is specifically bonded to the hydroxide ion. So we're going to look for something like this that is NaOH. Or it could be something like BaOH2 because barium's in group 2 and it uses a +2 charge. So we have a metal bonded to the hydroxide. The most common bases that we need to recognize and utilize are on our reference table L. Now, what makes a structure function as a base in solution is that these particles produce the hydroxide, the OH negative ion in water. The pH of a base will be greater than 7.0, and the reason is due to a lower concentration of the H plus ion. So notice it's pH. That H is in reference to what's going on with the hydrogen ion. Now, bases, they're not as common in foods. However, if there is a food safe source that has a pH of greater than 7, the taste is going to be bitter. And bitter is a different sensation on your tongue than like sour tart. Bases feel slippery. An acid, if you get some on your skin initially, it just feels like water, right? But a base, if you get it on your skin, it feels slippery. It feels like that soap that you can never wash off. And if the base is strong enough, where the P value is high enough, and you get some on your skin, it will burn your skin. Bases also function as electrolytes. Their solutions conduct electricity. And bases, they participate in a neutralization reaction, so we neutralize a base by reacting it with an acid.